So in the next section, we'll be moving on with the data plane concept. So in the data plane concept, we need to mainly understand the VXLAN. VXLAN stands for Virtual Extensible LAN. It is a kind of a technology which was introduced, the same like the concept of the VLAN, which has been extended and supported to VXLAN. So the main difference between the VLAN and the VXLAN we'll see. But again, the main reason, if you talk about the VLANs, now the VLANs allows you to create an isolated network. Like we can create a users on the VLAN 10, and then I have a users on the VLAN 20 marketing department. And if you want to logically separate, or if you want to isolate the traffic between the two different departments within the same layer 2 network, we do that. That's what the VLAN concept we used. But again, the limitation with the VLANs is this VLAN is restricted to the layer 2 network, which means if you have the same isolated network here, let's say I have a VLAN 10 and I have VLAN 20 in a different data center or different branch office or different location. So this is isolated. So in between, you have a layer 3 network, and basically the VLANs are not going to span over the layer 3 network. But now with the concept of the VXLAN, we can do that. So with the concept of the VXLAN, we can create a VLAN 10, and we can have a VLAN 10 here, and this can be part of the same network or say communicate over the existing layer 3 infrastructure. So that is something what made the VXLAN possible. So in simple terms, we can say like the VXLAN is the similar concept of the VLAN, where it allows you to span your layer 2 network over the layer 3 infrastructure between different branch offices. Typically, the typical example can be like you have a data center in head office, and then you have another data center or another branch office where you want them to be a part of the same network or part of the same department. So the VXLAN, as I said, it is going to provide you a kind of a virtualized technology, which provides you the scalability as well as the flexibility in terms of designing the virtual networks over the layer 3 infrastructure. So again, it addresses most of the limitations what we have with the layer 2. So if you talk about the traditional layer 2 networks, they use a .1q encapsulations. Like we know this, we have a switches, and then we have a .1q encapsulations, which will carry the VLAN traffic from one switch to another switch. But this is only spanned on the layer 2 links, but not on the layer 3. So with the help of VXLAN, what we'll be doing is we'll be using the same thing over the layer 3 networks, which means in our case, like I said, in our case, we'll be connecting the switches. Like take an example, we got a switch, interconnection is there. And in the case of layer 2, if you compare the same thing here, if I just compare the same thing in the case of layer 2 network, we traditionally run STP, and this STP will be responsible for deciding which path will be used. So again, there will be an ARP protocol which will resolve the MAC addresses, and likewise, and the host within the same VLAN can communicate with each other. So if you have a VLAN 10 user, and the VLAN 10 user can talk to each other, and the links between the switch to switch will be .1q links, and it uses .1q trunk links in order to provide the communication, and the decisions will be taken by the spanning tree protocol. Now this is changed now. Now, if you compare the same thing with a VXLAN, so the first change is we do have the connection between the switches, and these will be layer 3 links. So which means there will be no STP. We don't have the STP here. So instead of STP, we'll be running OSPF, and there will be an IP address assigned, and there will be, we'll be running some kind of OSPF protocol to exchange the information, like how many routes are there to reach one switch to another switch. And every switch will have its own IP address, just like we have a router ID concept, typically the loopback interface. And based on that IDs, the switches will be identified. And with the help of the OSPF routing protocol, which will enable, the switches will learn about the information about how many connections are there, how many possible routes, the complete information. So the thing is here, the layer 3 routing with the help of OSPF is going to provide you the flexibility, of course, the reachability and flexibility as well. At the same time, we can segment the network traffic with a similar concept of the VLAN. So one of the major change, if you compare this part with the traditional layer 2 networks, is we don't have the layer 2 links, we don't have the STP, we don't have the .1 link, we just have the layer 3 links. And again, one more thing, as I said, each switch will be identified with the ID. Like I said, every switch will have its own identifier, which will be used for identifying that particular switch. Like, let's say if I want to go to this particular MAC address or the IP address, you have to go to switch 2 with an IP address of 2.2.2.2. That will be the route ID. So it will figure out how to reach the switch 2 based on the OSPF protocol or the routing information it actually learns. So every switch will have its own identifier, typically the router ID, we can say, and most likely it will be the loopback interface IP address. And this way, every switch will have a unique ID as well. And the next thing, as I said, the layer 3 switches basically they run the OSPF to advertise those loopback interfaces. So once they have their own, once they have the IDs, the switch IDs or the router IDs of those particular switches, so they will come to know how to reach this 1.1.1.1. There are two possible routes. We can go from here or here. Then the best route will be decided automatically based on the OSPF routing, which we are going to enable for communication. So for learning the information, we'll be advertising them. So in the VXLAN, basically these loopback interface IDs will be the router IDs, which will uniquely identify each other. And they learn this information through the routing protocols, what we discussed. Similar to that one, as we move on, we'll see in the practical implementations in the later on sections. Now, again, there is one more thing here. The MAC address and the ARP packets are encapsulated over the IP packet. Like I said, with respect to the VXLAN, now you will have, like I said, you have a layer 2 network. Let's say we have a VLAN 10 and the VLAN 20. And maybe this is in my head office. And you can have another VLAN like VLAN 10 and the VLAN 20 or something like that. In fact, we don't have the VLANs here. In fact, we call it as VNI. Again, we'll talk about this, what is VNI. So we don't have the similar concept of the VLANs, but the logical separation concept is the same thing. Now, as I said, in the case of VXLAN, we are going to span this over the layer 3 network, which means you have your head office, let's say in Hyderabad here, and you got another branch office or a head office in Dubai, and you're connecting over the layer 3 service provider network, maybe through some routers, intermediate connecting through that. And as the packets is being encapsulated over the layer 3 network, so which means you still have the same MAC address resolution internally within the layer 2, within the LAN. You still have the ARP, which will resolve the MAC address from IP to MAC. And these packets are encapsulated over the IP packet because the resolution might not be within the same subnet. Like you might be trying to communicate between the A device, which is here, and might be you're trying to communicate with the B, which is on a different layer 3 network. Now, in this kind of scenarios, as the packet is not just going within the layer 2, because if it is going within the layer 2, then probably .1q trunks, the traditional switching method will be sufficient. But as the packet is transported over the layer 3 network, there must be some kind of IP encapsulation, the layer 3 IP packet encapsulation, which will ensure that your packet reaches the destination. So the MAC addresses and the ARP packets are still used in the VXLAN environments, but the only difference is it will be encapsulated over the IP packet. So if you try to see here, the encapsulation packets here, you can see there will be an original Ethernet frame. You still have the Ethernet frame, and on the top of it, you will have the VXLAN header, and also it will add some IP header as well. So IP header, those additional information will be added. Now the VXLAN is going to encapsulate the layer 2 Ethernet frame to transmit over the layer 2 network or the layer 3 network. like I said, your Ethernet packet will be transferred over the layer 3 network. This is layer 3 over the layer 3 network. Like I said, the traditional network, traditional technology of the VLANs and all those things works only over the layer 2. But whereas with the help of VXLAN, we are going to transport the packets over the existing layer 3 infrastructure. And again, the entire information will be transported. And typically, this transfer data between the endpoints is basically tunneled. Tunnel means because when we are doing the transportation, like I said, the example here, if I take an example in my case, so if I just go back to my previous topologies here, now in this topologies, as this switch is responsible for doing the initiating the packet, and then there is another switch which is on the remote side. So there will be a tunneled option. So these devices, again, we call it as virtual tunnel endpoints, VTEP. We'll talk about this. And there will be a tunneled process here. So which means your entire packet encapsulation is done. And essentially, it is going to do that with a logical tunnel. So there is a logical tunnel will be established between the source and the destination networking devices, which is going to simply encapsulate your packets inside that. So this is more like as if you have a virtual switch connecting between the two endpoints. So it looks like, even though in general, if you see, normally it looks like, even though at the end back end here, you have a layer 3 transport network, which is built, but on the top of it, it looks like as if you have a virtual connections established. So there will be a tunneled kind of behavior here. Now, why it will do that? What is the reason? If you ask me, the reason for that is simply to encapsulate over the VXLAN, because the IP packet, because the entire packet is IP based, and probably we are transporting over the layer 3 network, so it requires some kind of encapsulation. Okay, and also it provides you some kind of flexibility as well. And one more thing you need to know is you don't need to have all the devices to be enabled with VXLAN. Means whatever the transport network in between, like in my case, let's say there's the transport networks, like we have some intermediate devices which might not be enabled with VXLAN. Means there might be traditional layer 3 routers connected. You don't need to be running or understanding the VXLAN concept, because at the end, the edge devices, now this device and this device, they need to understand the VXLAN. But whereas the intermediate devices, the middle devices, they don't need to understand the VXLAN. Means they just do the normal layer 3 routing based on the IP packets. So in simple, if I quickly summarize the VXLAN, now at the end, VXLAN takes the help of Lisp protocol. Lisp is something you have seen in the previous sections. So basically, they work with each other to facilitate the communication, because at the end, you need to have the Lisp database and those things. The control plane information is required in order to make sure that where exactly it has to forward, right? Because the simple concept at the end, the control plane provides you the information of how and where to forward, and data plane will actually forward the packets. So that's the reason we can say the VXLAN is going to be a data plane option or data plane protocol. But at the back end, in order for the data plane to work, you need to make sure that you also have the control plane database built, which requires a complete guidance on where exactly to forward and how exactly to forward, to make sure that your packets are being forwarded inside the VXLAN network.